So during last session, we have completed how to calculate empirical as well as molecular formula. And regarding that, I have got very few assignments from you, and most of the student have not sent. I don't know whether they are following or not, but who all are sent to me assignments, their answers are almost same, right? I mean, almost correct. So, okay, let it be. If they are attending or not, it up to them. Later we will see in our offline classes, right? So, with this, today we will see one more part of this same chapter, that is some basic concepts of chemistry. In that, we have limiting reagent, right? So, limiting reagent. What is limiting reagent and what is the use of it? We will see. So, it is a type of reagent which is completely involved in the reaction, right? It is a type of reagent which is completely consumed, you can say, or completely involved, one we can say. It is a type of reagent. If you want, you can have this. It is a type of reagent. It is a type of reagent which is completely consumed in the reaction. Completely consumed in the reaction. Completely consumed in the reaction is nothing but what? Limiting reagent. So one example we will take so that one you can understand very easily. So if methane reacts with air, right? Methane reacts with air, it gives, right? Whenever a carbon and oxygen will come closer, I mean, whenever there is a combination of carbon and oxygen, definitely one we can produce carbon dioxide. Plus, the one more thing is left over here. What is that? H and O is almost over, but to balance the H, what we require is in our redox reaction chapter we have why we use to balance these H and O alternately, right? So here there are H. So H is nothing but H2. Carbon dioxide as well as H2 gas production is impossible in a same reaction. So now the one more possibility is to produce water molecule. So water molecule, if I want to produce, then definitely it will be a H2O. So now this reaction we have completed in a balanced equation, right? So you might have know these, right? So now balance our hydrogen, definitely one we can automatically balance the oxygen, right? So balance the oxygen. How many hydrogens are there? 4. So that means 2 2s are 4. But now count the number of oxygen. 2 plus 2, right? 4. 4, that means you multiply this with the 2. That means our equation is balanced. So now how to identify a limiting reagent in any chemical reaction, right? So here CH4 is a limiting reagent, right? See here, CH4 is limiting reagent. Why? Because see, oxygen is present in excess amount in the air. So we have took the oxygen from the air. From in air, what we can imagine in the air, oxygen is more, right? So oxygen we will get from the air itself. So that means if we expose our methane gas into the air, then definitely what happens, that methane gas will be consumed completely into the what? Oxygen. So that means what we said, it is a type of reagent which is completely consumed. Not here, the oxygen is not completely consuming here in this reaction, but methane is completely consuming. Why? Because its concentration is less in the air. See, what I am doing is, I am just taking a methane molecule and I am just exposing it into the air. So if I expose it into the air, then definitely what happens in the air, the more number of oxygen molecules will be there, should be there, right? So what they will do, they will, if it is a methane, then definitely what they will do, they will surround this, methane molecule. That means which is completely consuming in the reaction, methane is completely consuming in the reaction. Why? Because we took oxygen in the excess amount, right? Or else one we can say who is having less amount, but in all the reaction one we cannot say this what I am going to say now, that means, so which is present in less concentration is always a limiting reagent, but it is not possible for all the cases, right? So say for example, if I take a water molecule as well as the sugar, then which is the limiting reagent? Water always we will take in an excess amount, and we take sugar in a less amount. That means solute and solvent one we can say. But which is the limiting reagent among water and sugar? Definitely a sugar is the limiting reagent. Like this one we can say, which is completely consuming in the reaction is nothing but what? Limiting reagent, right? You have so many number of examples in your book, you please go through it, right? So later after this one we can say, next part of this is nothing but reaction in the solution. So how the reaction takes place in the solution, right? We need to see that now. So reaction in solution, reaction in solution. So definitely solution means we already know. I have already gave a introduction and all about solution, solvent, and as well as solute. So now solution is nothing but what? So again I remind you, solution is nothing but solvent plus solute. So whenever there is a solvent as well as a solute in a mixture, then that is nothing but a solution. And solvent is nothing but it is a component which is present in more concentration in the solution. It is a component or a substance which is present in less concentration in a solution is called as solute, one we say, right? So as I said, in our laboratory or in our chemical laboratories, whatever the reaction we do, 90% of reactions are in the solution medium only, right? So that's why what we say is water molecule is a universal solvent. Why? Because the water molecule is having a capacity to dissolve or soluble, make a soluble to all the 90% of the components or substance present on the earth crust. Why? Because it has a capacity to react with those molecules. And hydrogen bonding, what we say, right? So hydrogen bonding is very common. If a hydrogen bonding is taking place in a molecule, then definitely that will be a what? That will soluble in the water molecule, one we can say, right? So if it not able to form a hydrogen bonding with the water, then definitely that will be not soluble in a what? Water molecule. Just like if I mix a water with the oil, any liquid or anything, then definitely why they are not? That means they form a different surfaces or areas. Like one we can identify that this is a oil and this is a water. Why? Because they are not forming a bond with each other, right? If they are why? Because it consists of carbon, and this carbon will not form, carbon with long fatty acid chain, one we can say, right? So it is not soluble in water molecule very easily. So that's why what we say, wherever there is a hydrogen bonding formation takes place, definitely that will be dissolved in our water. If it is not dissolving, means one we need to we can directly say that definitely that molecule is unable to form a bond with the water molecule, or else directly when we can say hydrogen bond with the with that particular molecule. So likewise, when we see the 90% of our chemical reaction in the solution, so that's why solution is nothing but what? Solvent plus solute. So solvent is nothing but it is a substance present in a solution with more concentration, and solute is nothing but what? It is a substance which is present in less quantity in our solution, when we can say. So this is about the again brief introduction of what? Solution, solvent and solute. So to see the reactions taking place in our solution, we require some more terms, right? So those are very important. First one, concentration. Concentration. So what is concentration? We will go one by one. So after knowing solution, solvent and solute, definitely one we need to check what is a concentration. Concentration, the number of solute particle, the number of solute particles present in a solution is called concentration. Very simple. So if we know what is solution is nothing what is solution, then definitely when we can know what is concentration. I mean the number of solute, right? Solution is nothing but what? Solvent plus solute. So solute is nothing but less concentration, and solvent is nothing but more concentration. So the number of solute particle present in a solution, that means how many number of solute particle present in a solution, if we calculate that, then that particular term is what? Nothing but concentration, right? So to make a solution, what we require? Solvent as well as a solute. So definitely solute is nothing but the number of solute particle, right? I mean concentration is nothing but the number of solute particle, not solvents. Why we are not calculating the solvent is nothing but its concentration is more. So if the concentration is more, then that quantity will not be depend on a rate of a reaction. So that's why solute, the number of particles, single particle, how many number of single particles are there in a particular solution, then definitely that term what we call concentration. So with this we will conclude, and later in the next class we will see molarity, molality and mole fraction. These are also very important part, right?